So this will be the lessons 8, 1, 2, and 3 that are due next Sunday night. So I'm going to show you a little bit of what we're doing on that. So let me put my camera on the screen here. Should be sharpen my pencil. Oh, fabulous, fabulous. All right, let me talk a little bit about what these 3 lessons are this week. This is in no way replacing going through the lessons, because I'm not telling you everything that's in all 3 lessons. That would take up our whole time for probably today and Wednesday, because there's a lot in these lessons. So I'm just giving a brief summary, just working an example problem from each of the lessons. And then you still need to go through the lessons, because there's a lot more information in there, and they show you all the steps to get through there. And I'm kind of jumping to the end of the lesson. Once you've gone through the lesson, this is what you'd be able to do. So don't take this as a substitute for the lesson in any means. But we're talking about factoring, and we're factoring kind of in 3 different ways in these lessons. So let me show you starting out. The first thing you got to know is just how do you find the greatest common factor? Because that's what we're looking at. What's the greatest common factor that we can factor out of something? So if we had 2 numbers, excuse me, let me say that we had 68 and 44. And we're wanting to know what's the greatest common factor we can pull out of 68 and 44. Well, this is how I like to do it. I just like to make little trees and factor out the smallest thing I can to start with. I want a 2. That's an even number, so a 2 will come out of there. So that is 2 times 34. So 2 is a prime number. We can't factor 2 down anymore, so I'm going to circle that. But 34, I can factor down to 2 and 17. 2 times 17 is 34. And 17 is a prime number. I can't factor any farther than 17. So the factors of 68 are 2 times 2 times 17. That is the prime factors, which means all of these are prime numbers, and they can't be factored down any farther than that. That's as small as they get. So let's look at 44. It is 2 times 22. 2 is a prime number, so I can stop there. 22 is 2 times 11. And 11 is a prime number. We can't factor that down anymore. So the factors of 44 are 2 times 2 times 11. So if I wanted to know the greatest common factor, what's the biggest number I can pull out of both of these numbers? They both have a 2, and they both have another 2, and that's it. They don't have anything else in common. So 2 times 2, 4 is the greatest common factor. I could take a 4 out of both of those numbers. If I factored out a 4, this would be 4 times what's left? 17. And this would be 4 times what's left? 11. 4 times 17 and 4 times 11. I can factor a 4 out of both of those. Okay, so with that in mind, that's how we factor out an integer, a number. Let's look at what we're doing in these 3 lessons. The first lesson, 8.01, would give you something such as this. 12x to the 5th plus 6x to the 3rd plus 8x squared. And it would say, factor that. Factor that. And we're like, what? What do you mean factor that? We got to pull out the greatest common factor like we did up here. So what we would have to look at first is the 3 integers, 12, 6, and 8. What's the greatest common factor? Just like we did up here, what's the greatest common factor we can pull out of each of those? So 12 is 2 times 6, and 6 is 2 times 3. So it's 2 times 2 times 3. Those are all prime numbers. 6 is just 2 times 3, right? 2 times 3. Those are both prime numbers. And 8 is 2 times 4, and 4 is 2 times 2. Okay. So 8 is 2 times 2 times 2. So there's all the prime factors of those. And what do they have in common? They all have a 2. And see, this has a 2 and a 3, and that just has a 3. But this doesn't have a 3. It just has 2 2s. So there's nothing that all 3 of them have left. Since that one only has a 3, and this one doesn't have a 3, 2 is as far as we go. So we can factor out a 2. All right. Now, what can we factor out? X to the fifth, x to the third, x squared. Well, x to the fifth is x times x times x times x times x, right? That's 5 x's. X to the third is x times x times x, and x squared is x times x. So they all have one x, and they all have a second x, and that's it. That's all I can factor out. I can figure out x times x, which is x squared. So that is all I can factor out of that. So now we need to figure out what's left. When I factor 2x squared out of each one of these terms, what do we have left? 2 times what would equal 12? We need a 6. So 2 times 6 would equal 12. X squared times what would equal x to the fifth? X squared times x to the third, right? Because we add the exponents when we multiply them together. X squared times x to the third is x to the fifth. So that's what's left in the first term. Now when we take a 2 out of 6, 2 times 3 would be 6. X squared times what would be x to the third? X. Now to the last one, 2 times 4 would be 8. X squared times x squared. That's just 1. So when we take that squared out, that's all that's left. So this is the factors of this trinomial. Excuse me. So 2x squared times 6x to the third plus 3x plus 4 is the factor of this. Now, the third step that they show us, the first thing they do is figure out what is the greatest common factor. The second step is to factor it out like this with what's left. The third step is to check to see if we're right. And how do we do that? Well, we multiply it back together. So we have to distribute, right? We have to multiply this times each of the terms inside and see what we end up with. 2x squared times 6x to the third. 2 times 6 is 12. X squared times x to the third is x to the fifth. 2x squared times 3x. 2 times 6 is a positive. 2 times 3 is a positive 6. X squared times x is x to the third. And 4 times 2x squared is 8x squared. So these match. This matches this. So this is the correct factors. This is the correct factors, because when we multiply the factors back together, we end up with the original number. Just like up here, when we multiply 2 times 11, 2 times 2 is 4, 4 times 11 is 44. We get back to the original number. You should be able to take the factors, multiply them back together, and get back where you started. Same thing with a polynomial. Take the factors, multiply them back together, we should get back where we started. And we did, so this must be the correct answer. Okay, so that's what you're going to learn in lesson 8.01. So let me show you an example from 8.02. All right, let me see. Let me turn this over. We'll do it on the back. So in the second lesson, we learned to factor a little differently. We're going to factor by grouping. So it'll give us a problem such as like 10xy plus 3y plus 20ax plus 6a. And we're supposed to factor that. And we look at that and it's like, factor that? What do you mean? How can we factor that? Because like if I just look at the numbers, 10 and 3, this is 2 times 5, and that's 1 times 3. There's nothing in common there. I can't even get a greatest common factor out of this. How about 3 and 20? No. I mean, we don't have a common factor to start with. This is an x, y, and a y. So I can pull a y out of there, but this doesn't have a y at all. So it's like, I don't see anything I can factor out of there. This is where the factor by grouping comes into play. So if we group this, all right, so I'm going to say, all right, this is a group, and the second ones are a group. So what can I factor out of this group? Well, I still can't take anything out of the 10 or the 3 because there's nothing in common. But I can take that y out. So I'll say, okay, I can take y out, and that will leave 10x when I take the y out, and this equals just plus 3. So y times 10x is 10xy, and y times 3 is 3y. So that is factoring out the first group. Now, what can I factor out the second group? There's a plus. There's a 20 and a 6. 20 is 2 times 10. 2 is prime. 10 is 2 times 5. Those are both prime. 2 times 2 times 5. 6 is 2 times 3. Those are both prime. So it's got a 2. That's got a 2. So I can factor a 2 out. And then I have AX and I have an A. So there's an A in both of those terms. I can factor out an A. So what's left? 2 times 10 is 20. So I factor out a 2, that leaves 10. A factored out of AX just leaves an X. Okay. And then plus, those are both positive. Because 6 divided by 2 would be a 3. 2 times 3 is 6. And A, once we factor out the A, it's gone. Okay, so factoring by grouping, look what we have. We have Y times 10x plus 3 plus 2A times 10x plus 3. Notice those are the same. If we did it right, we should have the same number that both of those are. So if we factor this out of, we have 2 terms now, right? Terms are divided by some kind of arithmetic symbol. So we have this term plus this term. So we can factor a 10x plus 3 out of both of those terms. And then that leaves Y plus 2A when we factor it out. So that is the 2 factors of this. 10x plus 3 times Y plus 2A will equal this up here. Wow, that's totally different than the first problems, right? Factoring by grouping. By grouping. Takes a little practice. You start getting better at it. Again, step 3, we still need to figure out if it's correct. So we've got to go back and multiply them back together. So to do that, the first term gets multiplied by both numbers. And then the second term gets multiplied by both numbers. Both of the terms, both terms in this binomial. So 10x times y is 10xy. 10x times 2a would be plus 20ax. 3 times y is plus 3y, and 3 times 2a would be 6a. Are they the same? Let's do orange highlighter. 10xy, plus 20ax. Yeah, we have a plus 20ax, plus 3y, plus 3y, plus 6a, plus 6a. We're adding all the same 4 terms together. They traded places, those two. But it doesn't matter if we add 2 plus 4 or 4 plus 2, we get 6 either way. We can switch those terms if we're just adding. Doesn't matter which one we add first. We're adding them both. So this is the correct answer. This is the correct factors for this polynomial, because when we multiply them back together, it takes us back to what we started with. Factoring by grouping. Little different than we've done before. But the key thing is when you factor out, when you group them, you should end up with the same factor on both terms. Sometimes you may need to rearrange this. Let's look at another one. Let's say we had 3bx squared minus 9x to the third minus b plus 3x. If we look at that, if we group these, we can pull out a 3 and an x squared. But here, there's nothing we can pull out. Nothing. So that makes me think, okay, I need to rearrange these, because even though I can factor out this grouping, I can do nothing with the second grouping. And we need to be able to pull the same thing out of both of them. So let's put the b's together. Let's rewrite that. 3bx squared minus b. We'll just switch places with these two. Minus 9x to the third plus 3x. What if I group them like that, right? And make that my 2 groups. So let's factor out now with this rearranged. What can I pull out of here? Well, this is just a b, right? Minus b. So that's the only thing I can pull out. There's a b here also. So that would be b times 3x squared, because I factored that b out. And then minus b, if I factor a b out of that, it just leaves minus 1. Just minus 1. All right, what can I pull out of negative 9 and 3. Since the larger term, since the first term is the x cubed, is a negative, I'm going to factor out a negative 3 because I want to make that a positive. So negative 3 factored out of that. Oh, wait, I could also pull, look, I got an x to the third and an x. So there's one x that both of them have in common. So this leaves, when I take negative 3 out of negative 9, negative 3 times 3 would get me back to the negative 9. X times what would get back to x to the third? X squared. Oh, I'm getting the same term. That's what I want. If I take negative 3x out of positive 3x, that just leaves a negative 1. Looky there, I've got the same term. I've got the same thing in both terms, 3x squared minus 1. So I can factor out that 3x squared minus 1. And what does that leave? B minus 3x. There's a b in this term, and there's a minus 3x over there. There's our two factors. We just had to rearrange it to get it. Let's check it. All right, let's go back and check by multiplying the first term by both of those and the second term by both of those in the other binomial. So 3x squared times b would be 3bx squared. 3x squared times negative 3x would be negative 9x. X squared times x to the third. Negative 1 times b is minus b. Negative 1 times negative 3x is a positive 3x. Look at there, we have the same thing. That tells us that these are the correct factors. It all fell into place. Grouping, a little bit different. Just take some practice. You can get good at this. You can get really good at this. All right, let me try one more problem from 8.03. That is 8.01, 8.02. 8.03 would give us, let's say it gives us a trinomial minus x minus 4. And we want to factor this trinomial. And like, okay, well, I can't do grouping because I got 3 terms. I can't pull anything out of all 3 of those because there's no x over here. The 3 and the 4 don't have anything in common. So I can't do it like I did in lesson 1. This is the third way we look at things. So with the trinomial, here's what I'm going to do. I'm going to take the coefficient, 3, and I'm going to multiply it from the first term and the last term, negative 4. 3 times negative 4. I'm going to take the first term, last term, take the coefficients, just the integers, multiply them times each other. 3 times 4 is negative 12. Now I want to know, with negative 12, how many different ways can I end up with negative 12 by multiplying 2 numbers together, right? How many different ways? I could multiply 1 times negative 12, right? That would give me negative 12. Or I could have the negative 1 times a positive 12. That would get negative 12. But there's more ways to get negative 12 because 12 is also 2 times 6. So I could go 2 times negative 6 would get me negative 12. Or negative 2 times a positive 6, right? We can do both ways. Or how about 3 times 4? 3 times negative 4 or negative 3 times positive 4. That's all the different ways that I can come up with negative 12. If this was a positive 12, it'd be 1 times 12 or negative 1 times negative 12. Don't forget the negative options on all of these. There's always a negative option. So now that I've done this, using those two, what is the coefficient of the middle term? Negative x. The coefficient would be negative 1. That's the same as negative 1x. So the coefficient is negative 1. If I take these and instead of multiplying them, because multiplying is what I needed to get to negative 12, what if I added them together? Now I'm going to add these together. What's 1 plus a negative 12? Negative 11. I'm looking for a negative 1. That's not it. Negative 1 plus 12, positive 11. That's not it. 2 plus negative 6, negative 4. Negative 2 plus 6, positive 4. Still haven't found that. 3 plus negative 4. Negative 1. That's the one I want. I want the 3 and the negative 4. And of course, this one's positive 1. So I want the negative 1. So I'm going to rewrite this now. I'm going to rewrite this as 3x squared. And instead of putting negative 1x, I'm going to substitute these in there. I'm going to say plus 3x and minus 4x. And then minus 4. This is the same thing as this, right? Because if we combine those are like terms. If we had 3x minus 4x, that is negative 1x. So I took the exact same term and I just split it in half. Instead of having a negative 1x, I split it into a positive 3x and a negative 4x. Now that gives me the ability to factor by grouping because I have 4 terms now and I can group those. So in this first, I can factor out a 3x. See, there's a 3x in both of those. 3x squared and 3x. So I'll factor out a 3x, which leaves, when I factor 3x out of 3x squared, it just leaves 1x. When I factor 3x out of 3x, I just multiply it by 1 to get back, right? 1 times 3x will get me back there. Now I have negative 4x minus 4. What can I factor out of both of those terms? Minus 4. What does that leave? Minus 4x divided by the minus 4. I just need to multiply by an x to get back. What do I need to multiply negative 4 by to get to negative 4? Just 1. Look what we've got. We've got that same binomial that we can factor out of both terms now. X plus 1 times 3x minus 4. That is, there's the 3x minus 4, right? It goes right there. Let's multiply these back together to see if it was correct. X times 3x is 3x squared. X times negative 4, negative 4x. 1 times 3x is 3x. 1 times negative 4, negative 4. This simplifies, right? Like terms. 3x squared. Negative 4x plus 3x is a negative x minus 4. We're back to the original. So these are the factors. 3 different ways. 3 different ways that we can do factoring. 3 different ways you can do factoring. So lesson 1 is just pulling out one term that you can factor out of all the other terms for the polynomial. Second one is factoring by grouping. And the third one, we have to rewrite it and break the trinomial into 4 terms, and then we can factor by grouping. So that's going to be the 3 things that you're learning this week. That'll be the 3 assignments that you'll be practicing and doing those things. So go through the lessons. Make sure you do the practice problems in the lessons. It will work you up. I did kind of like some of the harder ones that are towards the end of the lesson, right? Because it'll do some simpler things, building up and going through the process it takes to get to this. So I just want to show that. Anyone have any questions on that? I know you haven't gone through the lessons probably. Some of you may have, but you probably haven't been to the lessons. So it's maybe the first time you've seen this and you're like, whoa. But that's why this is recorded. So you can go back and look at this after the lesson and see if it makes more sense. Or if you have some specific questions you have now, we can go through that.